In today's lecture on fundamentals of cryptography, we'll try to understand some of the basic concepts on cryptography. Now, it's a CompTIA Security Plus certification course. We're trying to cover most of the topics which would be required as far as the exam is concerned. Now, let's try to understand that what's cryptography. Cryptography is a technique of securing the communications in presence of third parties called adversaries. So if we want to communicate on the internet and we want to send some messages, which could be a confidential information, or we don't want anyone else to gain access to our information, the way we encrypt the data is called cryptography. Now, in cryptography, you'll have these three basic terms: plaintext, ciphertext, and clear text. Now, let's try to understand what is it. We'll go through it, and then whenever I think that there is a need of having a hands-on exercise on that thing, we'll be covering that as well. So plain text is the original readable text or a message that is fed into the algorithm as an input. So any text that we see on the screen in a clear text which we can read easily is a plain text. Then we have a ciphertext. This is unreadable output of the algorithm which conceals the plain text context. So if we are converting a plain text into a kind of a language or words or a string which does not make any sense, but it is a mixture of numbers and alphabets or different symbols, etc., that's a ciphertext. Then we have a clear text, which is often used interchangeably with plain text to denote the unencrypted information. An example is sending an email that is encrypted from a plain text to ciphertext to prevent unauthorized access. Now, we have different methods of concealing data. The first technique that is used to hide information is the non-secret data or the metadata. Now, there is a metadata behind the main data. We'll see it in a minute, but let's see what is Steganography. It's concealing the data within the other non-secret public data, ensuring that every existence of the data is concealed. Now, whenever we are talking about Steganography, it hides the existing data. It could be an image, an audio, or a video file that can contain the hidden message or the embedded in a file, etc. It is usually achieved by dividing the data and hiding the unused portion of the file. We usually use the image files, etc., in order to hide certain information on it. Now let's try to see practically that what do we mean by Steganography. Now this is a website, for example, Steganography online, and then we have an encode and a decode over here. So if in case we want to encode an image and we want to have certain information in it, so we'll have to load a picture over here first. Now, as you can see, I have added a picture, choose file and select a picture. And now I want to add some hidden information in this one. I'll enter it and then I'll press encode. Now, this is a binary representation of the code which is there for the text which would be embedded in this picture. Now, as you can see that the original picture is this one and we have normalized it. And there is a hidden message in this picture, but you cannot see the message as we entered hidden information. First of all, in order to see the message in this one, since we have encoded the file by clicking encode, we'll save the picture and then we'll click on decode. So in order to save the picture, you can simply right click on it and save the picture. Now, once the picture is saved, we have downloaded it as download.png, and then you'll click on decode and you'll choose the download.png file. Now, as you can see, the file has been loaded as the input, but now if we'll click on decode, you can see this information which is hidden in this and it has been displayed up here. So that's how we conceal the information. So whenever we try to hide information in audio files, video files, or audio files and transferring it online, this process is called Steganography. Now the next topic here is metadata, information that describes other data which can be inadvertently contain secure or sensitive information. Now, it's a common scheme to hide the data in a file header that contains or describes the file between the sections is called a metadata. Now, the metadata can be used to describe the content or the structure of the actual file. We can find the metadata about pictures. We can find the metadata about the documents. This is the information which is available for that specific document or file, but is not shown if you'll open it. Now, just to give you an example of a Word document. Now, in a Word document, if you'll open it, you'll find the content of the document, but we are checking the properties of that document, and you can see the location where it's saved, its size, size on disk, when the file was created, when it was modified, and when was it last accessed. Further, if you'll click on details of it, you can find the information of the author who actually wrote the document. When was it last saved, the content created, on which date, when was it last saved, and other relevant details about the document, like how many words are there, characters, line count, and other information. Now, of course, if you'll open this document, you'll see the content of the document, but all this information which gives us information about a file is called a metadata. We can also say, as an example, that embedding a secret message within an image file or using the steganography or a metadata in a photo revealing the location where it was taken. So in the pictures also, if you will open it in a, for example, a photo editor, you'll find EXIF information that would give you details about the picture, when it was taken, what kind of camera, how many megapixels, so much so that you'll be able to find the geographical coordinates of the picture as well. Now we have fundamental techniques for core concepts of cryptography. These are the methods of the cryptography used for secure digital information. Cryptography, the overreaching practice of securing the confirmation, the communication. Then we have stream cipher and block cipher. Now, in stream cipher, it encrypts the individual characters of a plain text message one at a time. So it would take one character in a plain text at a time, and it would convert it into a ciphertext. Now, of course, since it's taking one character at a time, it takes more time, but it is more secure. Whereas on block cipher, it encrypts the fixed size blocks using the deterministic algorithm. So it would take a fixed length and then it would convert it. So of course, block cipher is much faster than stream cipher. Now, example is using a stream cipher to encrypt a real-time communication data, just like we have secure voice calls, etc. Now, we have different types of cryptographic algorithms categorized in algorithm based on their operations or principles and key management, etc. So just like we defined earlier, for cryptography, it's a practice of transforming or scrambling the information so that the meaning cannot be understood by the unauthorized parties. Now, in order to make it more secure, we have two known algorithms which are called as symmetric and asymmetric algorithms. Now here we are not talking about hashing. We'll be covering hashing in a while, but at the moment we just want to see what is the difference between symmetric and asymmetric algorithm. Now, if we'll explain symmetric cryptographic algorithm is using a single key for both encrypt and decrypt the information. So since it's using the same key to encrypt and decrypt, that's why it's called a private key cryptography as well. Because the key is kept private between the sender and receiver, and if the key is compromised, your information would be compromised. Now, symmetric cryptography can provide strong encryption if the key is kept secure between the sender and receiver, and the known strong symmetric cryptographic algorithms are Advanced Encryption Standard, AES. You might have seen it when you are configuring your routers at home, or the other algorithm for that is Blowfish or Twofish. The next algorithm that we have over here is asymmetric cryptographic algorithm. It employs a pair of keys, one public and one private, for encryption and decryption. That's why it's called a public key cryptography. Now, the primary weakness of a symmetric algorithm is that distributing and maintaining a secure key among multiple users poses a challenge, whereas in asymmetric cryptographic algorithm, it uses two mathematically related keys known as the public key and a private key. The public key is available to everyone and is freely distributed, whereas the private key is known only to the individuals to whom it belongs to. Now, the example we are giving here is using AES for symmetric encryption of the data and REST for RSA, and the asymmetric encryption for emails, etc. Now, as you can see in symmetric encryption, if we want to convert a plain text into a ciphertext, we'll use one key, and the same key will be used by the recipient to decrypt the information. It's just like that if you are setting up a password on a WinZip file or a WinRAR file, you'll have to set a password on that, and then if you're sharing that file with someone else, you'll have to share the same password with the other person so that they can use the password in order to unzip the contents of the folder or the zip file. So it's a single key that is used in order to encrypt and decrypt. Now, the keys could be quite lengthy. You cannot memorize it, as you can see. For example, if this is the key for encrypting or decrypting the file, so of course you'll have to send it via email, a message, or maybe share it on the network. And that's the problem, that if you're sharing these keys online and if they are compromised, your information would be compromised. Now, in asymmetric key encryption, as we discussed, that it's called a public key cryptography because it has a private key and a public key. So every person would have a public key and a private key. Now let's try to understand in context of Elise and Bob. Now Elise would have a public key and a private key. Bob would have a public key and a private key. So how it happens is that public key, as the name indicates, it's for public. You can openly share it with anyone without considering that it would be compromised or anything. But if it's a public key, which is for me, there is a relation between my private key and public key. So my public key is available for public. For Elise, she can share her public key. Bob, he can share his public key as well. But both of them would have their own private keys. Elise would have her own private key. Bob would have his own private key. So now if Elise wants to send a message to Bob, what Elise would do, that Elise would use her private key, and since public key of Bob is publicly available, she'll use his public key to encrypt a message that Bob would receive. Now, Elise used her private key and Bob public key to encrypt a message. Once Bob would receive the message, Bob would use his private key, and again the other way around, he'll use the public key of Elise, which is publicly available, in order to read the message. So in that way, we didn't share any information of the keys online. Only thing that we shared and which is openly publicly available are our public keys. All you need to worry about is that if you want to encrypt a message, you'll use the public key of the other person and use your private key to encrypt a message. Once the other person would receive it, he would use his private key and your public key in order to decrypt the message. That's how it goes on asymmetric encryption. Now we have hashing algorithms. Now, algorithms that convert data of any size into a fixed length hash value, which acts as a digital fingerprint, is called a hashing. Now, there are different components of it. For example, SHA, it's a secure hash algorithm family used to widely for secure and data integrity, and MD5 is an older hash function used for checksum, but is also considered valuable. Now, hash function create a unique digital fingerprint of a set of the data. It's also known as hashing. This fingerprint is also called digest, sometimes called a message digest or a hash, which represents the contents. Now, it's primarily used for the comparison purposes. Now, hashing is intended to be one way in that so that its digest cannot be reversed to reveal the original set of data. And hashing algorithm is considered secure as it has a fixed length in a unique and is original and is secure. So hash cannot be reversed to determine the original plain text. Now, for example, if you'll think of collecting hashes of folders in your C drive, so what you can do is that you can select, have a complete hash value of the files and folders on your computer, and you can maintain it. So in case if your system is compromised and you want to see that which files has been changed and which files has not been changed, you can do it by simply matching the hashes. If the hashes are changed, it means that those files has been modified, whereas the files where the hashes are not changed, we can securely say that these files were not touched by the adversary. Now let's see it practically, that how does it work. Now we are on a website where we have a tool for text encryption and decryption. So if we are writing hello world over here and we want to encrypt it, we'll simply click encrypt and it would encrypt the text like this one. Now as you can see that it's an encrypted text where we have converted the hello world into set of hashes, and if we'll copy these hashes and paste it over here and click decrypt, it showed us the same message which actually we encrypted. So there is an algorithm which is used, and in this one we are using AES encryption. So it depends which kind of encryption you're using. You can encrypt and decrypt the message using those different algorithms. Now if for example we'll encrypt the message hello world, but this time we'll use a secret key over here, and I'll put in a key which is a very simple key 1 2 3 4 5 6 7 8, and if I'll try to encrypt it, you'll see that it's a different encryption output altogether as compared to this one which we had earlier. So if I'll copy this one and without providing the secret key, if I'll paste it over here and try to decrypt it, there is an error in this one because it knows that it requires a key, and since the key was not provided, it couldn't decrypt the message. But this time if I'll click on this one and I'll enter the key which was provided earlier and click decrypt, it would decrypt the message as we encrypted. So we used a single key in order to encrypt and decrypt the messages. Now let's see hashing on this website, and we'll try to convert a text into a hash value, and then we'll see that how does it work. So I have entered the text hello world over here, and I can select any algorithm out of these algorithms which are here. So if for example we are taking MD5 here and I'll click hash this text, so it would give us a hash value which is this one appearing on top screen. Now just for our reference, we have copied it in a Word document over here where we can see that hello world and its MD5 hash is this one. Now if I'll change it to SHA-250, SHA-512 bit, and I'll try to hash this text, you can see that this text is quite different than the one that we had earlier. If I'll paste it over here for SHA-512, so if we'll type in SHA-512 and we'll try to have the text value for this one, you can see that it's a very long set of characters over here, and the hash for both of them is quite different. Now if we'll try to change it again to MD5 and see that if it would give us the same value, and if we'll click hash it, the value now that we received over here is this one, and let's try to compare it with the one that we had earlier. So if I'll have it right next to this one, you can see that the value of hash 5 is exactly the same as we calculated earlier, since it is using an algorithm in order to convert the hash value of a file. Now let's try to have a text file, for example, and try to have its value or its hash value. Now as you can see that I have attached a file, create a notepad file, just like not this one but this one. I have created a file called hello world, and I have selected it over here, and I'll hash this file. So we selected MD5 algorithm for this one. So this time if we'll copy the hashing algorithm of this one and we'll paste it here, that's for the text file txt, and we'll paste it over here. And if you'll compare it with the one that we had earlier, you can see that the value of this file is a bit similar to the one that we had earlier because it's a text file with some information in it. Now if I'll make some changes to this file and I'll try to find the hashes for that, let's see the difference in that. As you can see, it's hello world. I'll just have a space after this one and save this file, and now I'll choose it again in order to find the hashes of it. And I have selected the file. I'll hash it now, and now let's try to compare the hash value of this file with a space at the end, and in this one I'll paste it, and as you can see, the hash changed for that file since there was a change. That's why I told you that in order to verify the identity of a file, if it has been changed or not, we can find it from the hashes. Now let's try to revert the change and see that if we'll get the same hash value as we had earlier. So we'll remove this extra space from here, save the document, and try to load the file again. Now we loaded the file, and let's try to hash this file again, and we have a output over here. Let's try to compare it on our document, and if we'll place it under this one, you can see that the output of this one is exactly to the one above, or if we'll have it right under it, so the output is exactly the same as we had earlier, and this second output was when we had a space after hello world. So that shows us that how helpful is hashing algorithm in order to find the integrity of files. So let's continue on benefits of cryptography. The advantage to provide cryptographic techniques is securing the digital communication and data. Now we have confidentiality, integrity, and authentication. Confidentiality ensures that the information is not accessed by unauthorized users, as we covered on module number 1. Now for integrity, it's assuring that the data has not been altered in any unauthorized manner, and authentication is verifying the identity of the users and devices. So if we are encrypting sensitive data transmitted over the internet to protect the personal information from theft, we use confidentiality, integrity, and availability, or authentication. Now we have advanced encryption techniques, and in this one, we have different techniques for this one. Now we do file and system cryptography. For that, we use encryption softwares in order to do to encrypt or decrypt files one by one. It's called a file level encryption. We'll be covering it shortly. Then there are third-party software tools available for encryption and decryption, which is GNU Privacy Guard, GNU PG, or AXCrypt, or Folder Lock, etc., or VeraCrypt, etc. Microsoft has the encrypting system, which is called Microsoft Windows Encrypting File System, EFS. You might have seen it in cryptography. And Windows is using it in order to protect the files on the systems. So we'll be looking at it shortly, but at the moment, let's try to understand these two concepts over here. First of all, we have full-disk encryption. We have disk encryption. It's also full-disk encryption as well. It's a volume level encryption and a database level encryption, secure data on the different stages. Now it protects all data on the hard drive. For example, Microsoft using BitLocker drive to encrypt the software that is included in Microsoft Windows. Now BitLocker encrypts the entire disk, including the Windows registry, etc. So if you're using Microsoft Windows Professional or an enterprise version, you'll find Windows BitLocker in that. Make sure that if you are encrypting the files, you're securely saving the keys for that, because if you lose the keys, there is no way to recover the data. Now, if we'll talk about volume level encryption, it protects the volume, which is a section of a drive that is accessible by the user. Maybe it might have a different file system associated with it, but it helps us in encrypting those files. Now, after that, we have self-encrypting drives as well, drives with integrated encryption mechanism. Now, all drives can protect all the data which is written on them. So self-encrypting drive would make sure that whatever is written on it is encrypted. The drive and host device perform the authentication process during the initial power up. And if the authentication fails, the drive can be configured to deny the access or even to delete the encryption keys. So all the data is permanently unreadable. Now, in order to do that, we have hardware security module and a trusted platform module. You might have heard it, TPM 2.0, which was required in order to install Windows 11, etc., which are the devices that manage the encryption keys and process within the secure hardware. Now, HSM is a removable external cryptographic device that includes an onboard key generator and key storage facility. It performs accelerated symmetric and asymmetric encryption algorithms. Now, if we look at TPM, it's an international standard for crypto processors that provides the cryptographic services. A TPM includes a random number of generator or a full support for asymmetric encryption and can also generate public and a private key. On Apple and Android devices, it's also called a secure enclave. Now we have digital signatures and file system cryptography. It's a technique to secure the digital documents and files across computer systems. We have digital signatures. We provide a mean to verify the authenticity of a digital message or a document or even a software. Now, file and file system cryptography, it protects the files on the computers and networks from unauthorized access. For digital signatures, we'll be covering in detail in our detailed lecture on advanced cryptographic algorithms. Now, digital signature algorithms create digital signatures which can verify the sender, prevent the sender from disowning the message, or can prove the integrity of the message. Whereas on the key exchange, there are different solutions for the key exchange that occurs within the normal communication channel. It could be Diffie-Hellman or the Diffie-Hellman Fernal or the elliptic curve algorithms, etc., or the perfect forward secrecy, etc., which are quite common for these kind of signatures on digital signatures algorithms. Now, since we were talking about that the other person cannot deny it, signing a contract digitally to ensure the non-repudiation using the file-level encryption to protect the sensitive files which is shared. So if a person is signing a digital contract, it means that the person is using his or her digital signature on it, so that no one else can deny it, because only you are the person who's aware of your digital signatures and your keys and private keys, etc. Then we have limitations and attacks on cryptography, recognizing the inherent limitations and the potential attacks that can compromise cryptographic systems. The limitations could be key management difficulties, resource and constraints, or the collision attack, or the birthday attacks, etc. Now, the limitations on the cryptography is a necessary feature to add to protect the lower power devices and applications with the fast response times to make them secure. Adding cryptography to a lower power devices or those that have fast response times can be difficult. Cryptographic algorithms require both time and energy, which result in a resource versus security constraints. Now, there are different kind of attacks. Two most common kind of cryptographic attacks are the algorithm attacks, or we call them collision attacks as well. Now, the method attackers can use to circumvent the strong algorithms include the known ciphertext attacks and downgrade attacks. Now, statistical tools can be used to attempt to discover a pattern in the ciphertext, which can then be used to reveal the plain text or a key. In a downgrade attack, an attacker forces the system to abandon the current higher security mode of operations and instead fall back to implement an older or less secure modes. Now, if we'll try to understand collision and birthday attacks, a collision attack is an attempt to find two input strings of a hash function that produce exactly the same hash output. When two files have the same digest, this is known as a collision. Whereas in a birthday attack, if we'll try to define it, it's based on a birthday paradox, which says that for there be a 50% chance that someone in a given room shares your birthday, where 253 people could need to be in that room for a birthday attack to take place. So that's about fundamentals of cryptography.